This is section 8.3, multiplying binomials. So last time we talked about multiplying a monomial times a polynomial. Now we're going to talk about multiplying two binomials. So a binomial has two terms. If you multiply something with two terms by another polynomial with two terms, you're going to end up with four terms. So for that reason, we have an acronym to help us remember to be sure to multiply all the parts that need to be multiplied. It's called FOIL, which stands for first. In other words, multiply the first terms. Outer. The outer terms are these two guys here. The inner terms, that's these two, and then the last terms. So we write the acronym FOIL and start doing our multiplication. We have x times x, which is x squared. That is our first term. Then we do x, the outer terms are x times 5, so that's 5x. And then the inner terms are 2 times x, which is 2x. And the last term is 5, the last terms are 5 times 2, which is 10. Now, when you're doing FOIL, you'll find that when you're doing a binomial times a binomial here, typically we have a variable term and then a constant. And the two inner terms are like terms, usually. And so we can combine those two together, giving us a trinomial. So x squared plus, if you add these two, you end up with 7x plus 10. And that is using FOIL to multiply a binomial times a binomial. All right. Next one here, we've got another way of doing this. Just a visual pattern. It's kind of like a Punnett square in biology. We've got this square grid. We can place one of the binomials with its signs along the top and another one along the side here. And then do the same process. Be sure to multiply each row times each column. So x times x is x squared. X times 2 is 2x. X times 5 is 5x. And 2 times 5 is 10. What you'll notice is that, once again, on this diagonal here, if you multiply a binomial times a binomial that's in the normal form, usual form that we'll see, you'll find that those two terms on the diagonal are like terms. So we have x squared plus, if you add the two like terms I circled, 7x plus 10. Same thing I got up here. So two different ways to do it. Some students like this visual representation right here using the boxes. The boxes will work for any size polynomial times another polynomial. I'll show you what that looks like on the next page. And then others like to just do FOIL, do the multiplication in your head, and then write down the solution. It's just a way to make sure that you do each multiplication that you need to do. All right, so we're going to use the distributive property, or FOIL, to multiply 2x plus 4 times 3x minus 7. 2x times 3x is 6x squared. Those are the first terms. The outer terms, 2x times negative 7, would give me negative 14x. And then the inner terms, 4 times 3x is 12x. And then finally, the last terms, that's 4 times negative 7, or negative 28. Combine the two middle terms, and you're left with 6x squared. Negative 14 plus 12 is negative 2. Attach the x, minus 28. All right, let's go ahead and do the boxes here. If you want to draw your own box, label one side x minus 3. Doesn't matter which, if you put the x minus 3 on the top or along the side. Same thing with the 4x minus 5, it can go either place. 4x times 4x is 4x squared. 4x times negative 3 is negative 12x. X times negative 5 is negative 5x. And negative 5 times negative 3 is 15. And we'll see on the diagonal here, right here, we've got like terms. So we're going to combine those two. So this is equal to a 4x squared. Combining the two middle terms is negative 17x, and then plus 15. All right, let's try one more here. We've got n minus 6 and 4n plus 7. So 4n times n is 4n squared. 4n times negative 6 is negative 24n. N times 7 is 7n. And 7 times negative 6 is negative 42. So once again, label the sides, do your multiplication table. Combine those middle terms. So we have 4n squared. Negative 24 plus 7 is negative 17n. And then minus 42 is my final solution. So do the boxes work with different size polynomials? They do. We have, this is a binomial, so it has 2 terms, and a trinomial has 3 terms. So we'll have 6 individual boxes. It's going to look like this. The 2x minus 7 goes along one side, the 3x squared plus x minus 5 along the top. And we have 6 individual boxes. We're going to find on the diagonals that we have like terms. 2x times 3x squared is 6x cubed. 2x times x is 2x squared. 2x times negative 5 is negative 10x. 3x squared times negative 7 is negative 21x squared. Negative 7 times x, negative 7x. And negative 7 times negative 5 is positive 35. What you'll notice here is that we have like terms in certain patterned places in the rectangle that I've circled there. So right at the top left, that has no other like term. There's no other x squared cubed term. So we write down 6x cubed. There are 2 x squared terms. We can combine those together to get negative 19x squared. The x's are also like terms. We can combine them together to get negative 17x. And then we have the 35 with no other like terms.